Okay, here we go. Here are our notes so far, right? Synthesis, when we take two elements and we smash them together to form a compound, right? Our single replacement is the third wheel reaction, where the metal is just, right, strong enough or too weak to kick the other partner out. I'm going to flip over, and I'm going to start our third reaction here. This is going to be our double replacement reaction. Okay. The double replacement reaction, our definition is when two ionic compounds switch metals. Okay. When two ionic compounds switch metals. Remember, we always write a general equation with letters. This is going to be AB plus CD forms. Now remember, the metal can only take the place of another metal. So I have to pair C with B and then A with D. Notice C is still the first in the compound and A is still the first in the compound. They've just switched partners. Right? Now let's draw our colors. Right? Let's say A is still green and B is still blue. Right? And let's say C is red and D is yellow. All we're doing is we're switching, right, the places of the red and the green. So that now red goes with the blue, and the green is now with the yellow. Okay. It is really as simple as that. Let's just make a little note here, right? Metals can only take the place of other metals. Okay? Only A and C can flip. I can't put A and C together because I can't have a metal with another metal. It doesn't make an ionic compound. I'm going to call this reaction the double date switcheroo. Do I call them equations? No. Switcheroo reaction. Right? Two compounds go to the formal, right? But then at the formal something happens and they walk out with opposite partners. Right? Everyone's still happy. They're just not the same partners that walked in.